For what we've seen in utility generation, if you're talking about strictly coal fossil units that you want to try to save in terms of a brownfield, but you're talking about, in a lot of cases, 40 or 60-year-old units. And, if you're really going to do something, it's more of a perception thing, and economics usually is what drives your training, right?
This is EnergyCast, and I'm Jay Downhauer. Today we are talking about extending the lives of power plants. Projects at existing sites are commonly called brownfield, whereas new developments are called greenfield. I say this in the panel I host in this episode that I believe that updating equipment or extending the lives of plants at brownfield sites is green policy. Think about it. You can reuse a lot of the existing infrastructure. This should make environmentalists ecstatic. Rather than going into a virgin spot of land, you're keeping the industrial expansion to a minimum. I have 3 guests in this panel, each representing fossil, nuclear, and renewables. The fossil guest is primarily focused on converting coal plants to natural gas. This has been popular with utilities because you're essentially swapping one fuel for another that produces the same reliable power output but half the carbon. My nuclear guest says their role is much more regulatory. Almost none of the hardware needs to be updated. Instead, they have to navigate a tricky maze of paperwork to keep operating, usually from a 40 to 60 year license, and now to 80 and possibly 100 years. My guest says this can allow the same nuclear plant to provide carbon-free power to another generation or two. And finally, renewables. My guest is mainly developing wind projects. Some of the oldest farms out there are only about 40 years old. My panelist says this is a dance between O&M and OEM. You replace the old OEM parts and you decrease O&M, which is the name of the game for utilities. I've often called these types of projects retrofits and been corrected that the proper term is repowering. I think back to the first time I came up on a powerhouse for a hydroelectric dam in South Carolina. The plant was built in 1919 and the president listed was the founder and namesake of the company today. That facility is still operating. So if one of our oldest electric technologies can still run reliably, why not all these facilities that were built more than a lifetime later? It should be in everyone's interest to make the most of these ageless assets. My guests today are 3 panelists I hosted for the virtual PowerGen Plus series last February. For nuclear, Richard Clubb is the West Coast Division Director for Intercon Services. My fossil panelist is Dennis Asowski, Director of Technology Development for Babcock & Wilcox. And my renewable guest is Eric Soderlund, Vice President for Consulting Services at Sargent & Lundy. All 3 of these companies are household names, and I believe all of them operate in the other 2 sectors. We also got into some talk about the recent snowstorms in Texas that hit in February and knocked out the power for millions. You'll remember that there was a lot of finger pointing among all 3 families of generation. I hope you enjoy my panel from PowerGen Plus, Asset Management for Plant Life Extension. Welcome everybody to this PowerGen Plus series. Our panel today is about making the most of our power production assets, and we have panelists representing nuclear, fossil, and renewables. And what's interesting about these panelists is that each of the companies they represent perform this work for all 3 of these energy families. So there might be crosstalk with our panelists. I certainly look forward to it. For nuclear, we have Richard Clubb for Intercon Services. For fossil, we have Dennis Asowski for Babcock & Wilcox. And we have for renewables, Eric Soderlund with Sargent & Lundy. And we are going to start it off with nuclear with Mr. Richard Clubb, West Coast Division Director of Intercon Services. Hey, Richard, what's going on?
Things are sunny out here in Oakland. My scope of purview is twofold. It's on the nuclear services side and servicing our clients out here. It's also supporting data centers and other industrial clients. So there is a little blend over on the panel I was mentioned up front. I'll focus primarily here on our nuclear services. We support the industries shown above through power generation, through the delivery delivery of it. We also have several government and critical power clients, particularly in that data center field. We're number 2 in nuclear power engineering. We're very familiar, have people on site, and support clients in 90% of the industry. And what we're talking about today really speaks to where we're going as an industry. I get really excited when we talk about taking our existing fleet, expanding it for another 20 years or another 40 years. Each one of those is almost another generation of people that can support facilities and continue to provide carbon-free power for the United States. As far as where is the industry, nuclear power plants are licensed by the NRC for 40 years of operation initially. The equipment was designed for 40 years plus. All of the components and pieces that make up the facility are designed to that envelope. And what we're doing is each time we extend that duration, we need to look back on what the cost is of extending it. We need to look back on the documentation and surveillances that we've conducted on the equipment and make a broad assessment on what needs to be done to go another 20 years, provide that documentation to the regulators, get it reviewed, hopefully get the thumbs up and proceed into that extended period of operation. And then, fortunately, do it again if the equipment and the economies support doing so. So here's just a quick snapshot of where the industry is. A lot of the items you might hear me talk about is a subsequent license renewal that's going not for the first 20-year extension, but going for a subsequent 20-year extension to a total of 80 years. So what's involved in that, just to give everyone an equal background, it does boil down to cost benefit. What are the costs? What are the risks? What has changed? And a lot can change over a period of time. You may build a facility 20 miles outside of Charlotte where nobody lives, and all of a sudden the city grows around you and you have to take assessment of how that impacts your emergency plans, how that impacts the staff that supports it, all of those items. It's really adjusting to the changes that have occurred over that time period. We do a cost benefit. We take into effect the risks. We go through all of the equipment in the facility that may not have the documentation or credentials to go another 20 years. We develop that, and we have regulator support with ex-NRC officials that support us to make sure that we do a dry run of sorts before it goes to the regulators. It gets approved, and then we continue to support the facility. Now with an additional 20 years of lifespan, and that 20 years also changed the equation on what capital improvements, extended power uprates, things of that nature might be warranted for that facility. That's a quick intro. I'll just end my intro on noting that Intercon was involved in the first SLR that was submitted and approved. It continues to be an exciting part of what we provide.
All right, Richard. Hey, thanks so much. Next, we have Fossil, Dennis Osowski, Director of Technology Development for Babcock and Wilcox. So what's going on the Fossil front, Dennis?
First, I would like to thank Jay and Rod and the team at PowerGen Plus for the opportunity. My name is Dennis Osowski. I've been with B&W since '99. Currently, I direct development of efforts to commercialize our newer advanced technologies. B&W, we are a long-lived boiler company, founded in 1867. We're a steam generation company that has a lot of other technologies that support that. We deliver that steam generation through the renewables and thermal business. Renewables are things like waste to energy, biomass, our traditional technologies of if it burns, we can put it in the boiler and make steam. And we're also moving now technology that's been worked on for a while. And Jay loves to talk about carbon capture. And we do have carbon capture. We actually developed this technology about a decade ago, maybe a little ahead of our time. But this is proven technology, both oxygen-fired combustion and what we call RSAT. But as everybody knows, these technologies do put large parasitic on our plants. In spaces where the technology makes economic sense, this can provide a coal plant with near zero carbon emissions, and it's very effective and it's been proven. But we're going to need help to get this technology to really get deployed. It's there, we're ready. We are getting a lot of interest in this and across the pond as well. Next, and more maybe applicable and what a lot of folks are seeing as a near-term lower cost approach is the whole idea of taking coal or oil units and converting them to natural gas. There's a lot of benefits in terms of the actual asset itself. Not that expensive. There is a lot of infrastructure that has to be built. You got a big high pressure gas line that you've got to get to the plant if you don't already have it, but it gives you an immediate CO2 reduction and a big one. And it also eliminates SO2, PM, acid gases, mercury, all that stuff just comes along with it. And you can shut down all the parasitic back-end equipment. You also get better ramp performance and better startup reliability on gas than you might with coal. So this is a super popular topic. And I actually lived through the first bubble of this in the early 2010s. There was a huge push on that. That had more to do with the mercury air toxic standards than life extension, but it was a strategy to extend life back then. Different drivers today, but there's still a lot of interest, right? Then we have marginal tricks that we can offer, things like this. We call it the variable temperature economizer, or VTEM. This is a device modification that we do to a coal boiler's economizer that allows the unit to turn down as much as 60% than without it. What does this buy you? Well, it lets you operate the SCR that's probably on the back end over a much wider load range. So when you're out of the money, but you got to stay on, well, this helps you not lose quite so much money, right? It can help in many cases an existing coal plant make it on the margins. And then finally, B&W recognizes the need that the future in energy is probably a lot of storage. And we're working on advanced technologies in storage. People are asking us about this all the time. And one of our first steps was to put into our portfolio a short-term storage method because it's ready. It's a different chemistry battery than your lithium ion, but it has a lot of benefits in terms of its thermal characteristics and the materials being non-toxic and friendlier than lithium ion. It's kind of an everything everywhere approach for us. And we're working hard to help our customers make the transition.
All right. Thank you so much, Dennis. We're going to finish up with our renewable panelists. It's Eric Soderlund, Sargent and Lundy. He's the Vice President of Consulting Services. Eric, tell us about what's going on with renewables.
Yeah, appreciate that. Thank you. And good afternoon, everyone. My name is Eric Soderlund. I'm a Vice President with Sargent Lundy. For those of you who may not be familiar, we're a large engineering firm that's been around for about 130 years, specializing in the energy and industrial sectors. I work within our consulting group and provide a lot of owners engineering and independent engineering services to the renewable energy industry. Thus far in the renewable energy industry, the topic of plant life extension has really focused on wind projects and what's called partial repowering. Partial repowering really took off after 2015 when Congress passed the production tax credits and made them available to projects such as onshore wind projects that generate renewable energy. The production tax credits, or PTCs, are quite literally what they sound like. They're a federal tax credit for projects that generate renewable energy. In 2016, the first year that they were eligible for onshore wind, they were 2.3 cents per kilowatt hour, and they were eligible projects. They were granted for the first 10 years of operation. The original plan was to ratchet the PTCs down each subsequent year, but there have been a number of changes to policy along the way. This year, in 2021, the PTC still exists at a rate of 1.8 cents per kilowatt hour for those projects that are commissioned this year. And the key for projects to receive those, or for repowered wind projects, is that they need to meet what's called the 80-20 rule. The 80-20 rule is really an accounting equation that dictates that a project is eligible for the PTCs after partial repower, so long as the value of the facility has 80% or more of it coming from the new capital expenditures associated with the repower. In other words, the repowered facility cannot derive more than 20% of its value from the existing depreciated assets. So what does partial repower look like physically? Well, it can take a couple different forms for the wind turbines themselves. Initial partial repower projects in 2017 and 18 typically involved replacement of the wind turbine rotors with a larger set of blades and a hub, replacement of the main bearings and shafts. And then there were select refurbishments that went along with it, such as the generator and the gearbox. Since then, we've seen a number of more creative repower solutions, such as one wind turbine OEM coming in and replacing the entire nacelle and above a wind turbine, that being entire assembly above the top of the tower, and replacing one wind turbine OEM's nacelle with that of their own. For the rest of the plant, typically the towers are maintained, always the foundation, sometimes with a bit of a retrofit, and the balance of plant, the electrical balance of plant is maintained as well, which consists, of course, of the collection system, SCADA system, interconnecting substation, and if it exists, a transmission line to the project substation is maintained, and there may be a transmission line to the interconnecting substation. So as you can imagine, a partial repower of a wind project involves quite a bit of engineering due diligence. We've broken that down into about 7 tasks shown here. Always the task that receives deserves the most attention is the wind turbine foundations. That's because the wind turbine foundations are designed with finite fatigue lives. And in most cases, the repowered project is being required to operate beyond those original fatigue lives. So it requires quite a bit of analysis and diligence. Of course, there's a need to look at the electrical balance of plant as well. And this is particularly true in the case of a capacity uprate of a project. There's a need to look at the wind turbine towers. This is particularly true. One wind turbine OEM repowers the wind turbine of another OEM and will often not provide a warranty for those towers. There's a need to look at the wind resource assessment, which of course is the probabilistic calculation of the project can generate after it's been repowered. And a need to look at the wind turbine technology itself and confirm that the repowered wind turbines will be suitable for the sites in consideration of the specific wind regime present. There's also a need to look at the commercial agreements, key one being the LGIA. With repowered projects, it's important to review those technical requirements and confirm that the repowered project will be able to meet them, or if they're not going to be grandfathered into the existing requirements, to understand what requirements will be present. I just need to look at the permitting, just as one example. If a wind turbine receives a larger rotor, as most do in a partial repower, the FAA permits probably need to be renewed as the tip height of the wind turbines will increase and invalidate the prior. Finally, we look at the O&M program for the repowered project and project the O&M costs going forward, which is an important part of understanding the cost of maintaining these facilities and the modeling and investment that supports them. So Sargent & Lundy has quite a bit of wind project partial repower experience in the last 4 years. We've performed that engineering diligence that I mentioned in the prior slide for 67 wind projects, and we're mobilizing on another handful of them as we speak, representing a total capacity of almost 8 gigawatts. Project initial CODs have ranged all the way from some particularly old projects dating back to the 1980s, all the way up to projects as newly commissioned as 2013, in locations throughout the United States. As part of this diligence effort, we've inspected over 4,300 wind turbine foundations and have climbed over 200 towers. We've looked at these repowered projects for quite a few wind turbine OEMs. Of course, the big names you'd expect to see there, GE, Siemens, and Vestas, but also some of the older wind turbine OEMs that no longer exist and are now being repowered by other OEMs such as Bonus and Clipper. With that, appreciate the opportunity to speak on that, and thank you for the introduction.
You got it, Eric. I'm going to start with some individual questions. And of course, I see that we've got a couple of Q&As coming from the people attending today. I'll try to get to as many of those as possible. Eric, the main driver for repowering wind farms, you mentioned this 80-20 rule. I think that's easy for us to understand. What are some of the main drivers for repowering a wind farm? New owners, you mentioned some of the old manufacturers, you're replacing that gear. Original assets have depreciated, new equipment that might be more efficient. What are some of the main drivers on some of these projects that you've done?
Yeah, absolutely. Good question, and one that we get asked quite a bit. The main primary driver, of course, is the production tax credits. But beyond that, we've looked at these 67 plus projects. We've noticed quite a few other trends that drive the need to repower. A lot of them are merchant projects without PPAs. They're experiencing low pricing, particularly in ERCOT. Many are experiencing poor availability and low capacity factors. Often they have high O&M costs, and in some cases, the lack of support from the original OEM. Partial repower offers the opportunity to remediate some of these issues, particularly the availability and the capacity, which you'd expect to improve the repowered projects. With newer equipment, you'd anticipate lower O&M costs, and of course, gain the support from the OEM of the repowered turbines.
Good point with the O&M. And then Dennis, on to fossil. I could talk about carbon capture all day long. I was executive director of a carbon capture association in Texas, but I'm going to talk more about converting coal plants to gas. That seems to be a hot issue, seems to be something that a lot of utilities are interested in, especially as they're trying to lower their carbon output there. It's captured the imagination, right? The public's imagination as well, but it's not ideal for every coal plant. What makes a coal plant ideal for that kind of project? What would maybe be an immediate disqualifier for converting a coal plant to gas?
Yes. Like I said, I was involved in the middle of the last bubble of conversions. And what we were hearing back then was the fact that the plant you want to convert needs to either have like transmission level natural gas already supplied to it. They already have a combustion turbine there or something like that, or they have an easy run to make to the tap. As soon as the pipeline got too long, or siting a pipeline was the biggest problem these folks were running into. And you got to go find a major interstate pipeline to tap into because it's got to be transmission quality gas. It's got to be at high pressure. And some plants want two separate lines. And if you wanted to to play the capacity markets in PJM back then. I'm not sure what the rules are now, but you needed 2 sources of gas from 2 separate pipelines. So that really was a big constraint. Most of the cost in a gas conversion is that pipeline and all of the processing equipment. But to that end, your boiler's got to be in pretty good shape. You don't want to have to go into the boiler and have to replace superheaters and major headers and that sort of thing. Though we've seen people do it. FD fans might be too small, air heaters might be leaking a lot. All that stuff might lead to capital costs that are just not, they don't work in the economic model. And then where that plant is on the grid, because you're going to be a peaker after you go to gas, right? What's your marginal pricing at that node? And can you make it? So it's all about the economic model. But from an infrastructure standpoint, man, it's that pipeline.
Yeah, I love this idea that it's like we can retrofit your coal plant. We've got a transmission quality gas line coming to it, and then they come back to you with, can you do 2? Yeah, those are good qualifiers. Richard, nuclear. We've heard so many stories about the regulatory environment just getting some of these new units. Is there a clear timeline for relicensing a nuclear plant? And I think 20 years can go by in a blink, huh?
Well, 20 years does go by in a blink. I'll certainly attest to that. So I'll share just one quick image to show a timeline that the NEI put forward for subsequent license renewals. It is a long process. We have a pretty good cookbook for going through that process. We look through the documentation, we look through the requirements, we add what additional inspections or items are needed, what different additional capital improvements are needed, and move forward. The nuance is, what documentation do you have available? How much of this are you ready for to go into the next 20 years? So if you were never planning to go for a license extension and all of a sudden going from 40 to 60 is a big surprise, you'll find just the documentation, getting it together, and the surveillances and equipment are more difficult. If you were a newer facility and let's say you recently went through the first license extension, then you had a lot of additional requirements because that recipe book got better and better as each unit went through the process. And so you're actually in a great place to jump in and do a subsequent license renewal once your timeline is up. It's really a documentation timeline and how you can get through that.
Good to know here. I'm going to go ahead and do a couple of questions here. This is for everyone. The first question we got was, how do you see higher input of hydrogen impacting gas-fired plants in the future in terms of operational efficiency, but also lifespan, or is it really a simple switch over time? So I'm talking a lot about hydrogen these days. I just did an episode about a company that has a new way to do hydrogen production that isn't electrolysis, so it's pretty exciting. So what about hydrogen?
I can say one thing on the nuke side, is I think all 3 of us will probably be touched by this, is there is an initiative the DOE is putting forward to situate hydrogen production co-located near nuclear power plants to help the economies of the production, and then take that hydrogen either as storage or to another facility to burn. I would suspect it probably touches all of us on the panel.
You're making hydrogen from the nuclear power?
Correct. So let's take a plant in Phoenix where there's a lot of renewable energy available during the day. You can produce hydrogen co-located near your nuclear power plant because you have a large baseload facility. And then you've produced and stored that hydrogen so that when there is the need for that additional power, it can be burned in a facility nearby. We actually have several clients looking into hydrogen production co-located near to baseload nuclear power plants.
In terms of impacting gas-fired plants in the future, I can't see folks wanting to burn hydrogen in boilers. It's going to be the champagne of fuels, right? You're probably not going to do that. Never say never, because 10 years ago, we never would have thought anybody would take a coal unit and put it on natural gas. If hydrogen's low enough cost, people might do it. But what they're really looking at doing is putting that into combustion turbines. And that work is moving along seemingly pretty well. And they'll be able to burn any blend or any combination of gas or pure hydrogen in these combustion turbines. And we do have small package boilers, and we build them and we make them already that burn hydrogen for industrial processes. It's only a tick less efficient than natural gas. And it's quite easy. There's considerations, but you can put hydrogen into a boiler. There might be some metals issues that you got to look at, hydrogen embrittlement, superheater metals temperatures, those sorts of things, but it's quite doable from a technical standpoint.
Yeah, I did an episode with Jeffrey Goldmere with GE, friend of PowerGen, using hydrogen in a lot of the turbines and everything. Eric, this one sounds like this might be more for you. Anyone else can answer it. How much does repowering an old wind farm with newer turbine technologies impact the capacity factor of the unit compared to the original? I'm sure some of those old wind turbines, you could see a lot of gains nowadays in 2021, right?
Yeah, absolutely true. And of course, it's project and equipment specific, but one way to kind of look at it is some of the original or initial repowers that involved primarily a rotor replacement went from an 87 meter rotor to a 91 meter rotor. And even though it's only 4 meters in difference in the diameter, when you actually look at the geometry of the total swept area, I don't recall the exact figures, but I think it's close to a 20% increase. That doesn't correlate to precisely a 20% increase in the capacity factor, but you can get the idea that there's quite a bit of additional energy to be harnessed from the wind resource through the repower. And that's not even in consideration of the opportunity to actually upgrade the wind turbines themselves. So in short, the capacity factor increase can be, quite substantial.
Yeah, it's really exciting. You're not really changing much with the diameter of the windmill.
Yeah.
Another question we got from the guest, probably more of a nuclear question. Utilities such as Exelon and Dominion are seeking 80-year licenses for some of the nuclear power plants. One of the biggest challenges is these 1970s era nuclear units make the transition to the 2030s and beyond. Where does the older plant need the most extensive work to live longer?
Yeah, I'd say the subsequent license renewal we're seeing so far is, I would say it's unique. It's difficult, but maybe not as difficult as the first license renewal because we've developed the documentation and processes and really kind of forecasted out what subsequent license renewal was going to look like through that process. I would say the first off, it will be difficult to go from 60 to 80, but maybe not as difficult as going from 40 to 60. There are some large scale risks to plants. Maybe it's water availability, maybe it's offsite power, maybe it's population centers, and each site kind of has to assess that risk and work their way through it from a regulatory space. But I wouldn't say that there's one issue. I think it's a specific issue to a few sites, hopefully, and hopefully many will go through without a lot of difficulty.
Are there any regulations you'd like to see to make these sorts of plant extensions more attractive? Maybe laws concerning depreciation, things that might sweeten the pot for some of your customers?
Just taking that question from my perspective, it's really the price of power and how we compete against other fuel sources in the market. Nuclear power in certain states is benefited by being a zero carbon technology. To the extent that those continue, that is a great benefit for that fuel source to be able to see that they'll have a steady stream of income that supports all the efforts to go through the process. As far as regulation, now that we've done several subsequent license renewals, we're moving from 60 to 80. The unknown is probably the greatest hindrance to extending the lifespan. Now that we've got facilities that have done it, we have go-bys, if you will, we have OE, and that uncertainty is a great effort. So more regulation or more forethought in going from 80 to 100, which seems like a ways off. I know there's already discussions on it, is what would benefit the nuclear industry.
And what about public policy and public perception? This brownfield versus greenfield, and what we're talking about here is upgrading these brownfield sites. My impression would be that extending the life of these brownfield sites is green policy, right? The land's already been developed. The public accepts that the site serves that purpose. It's been there for several decades in some instance. What are all of you seeing? It certainly would seem to make a whole lot more sense to improve what's already there and try to keep it going as long as you can, right?
Yeah, I think for what we've seen in utility generation is a lot of advantages. I mean, you've got large substations there and the power feed is definitely available. They're taking advantage of those sorts of things. Infrastructure's there, big roads, haul roads, all that sort of thing. But at least in our sector, and if you're talking about strictly coal fossil units that you want to try to save in terms of a brownfield, you're talking about, in a lot of cases, 40 or 60-year-old units. And, if you're really going to do something, it's a lot of money. So it just comes down to CapEx and OpEx. It's more of a perception thing, and economics usually is what drives your train, right?
Right. I hadn't, of course, planned for this when we were planning this panel, but I really wanted to touch on some of the news we've been hearing over the last week or so. I lived in Texas for several years. I worked, of course, in that coal foundation. I was there at the Texas Capitol, knew a lot of folks at ERCOT. There definitely will be an investigation about maybe why people lost power, maybe what generation assets might have worked or didn't work. All of you represent one of those families that I think people have questions about. But given what we're seeing now, questions about the windmills, the nuclear shutdown at South Texas project, and then, of course, the fossil plants with the gas supplies. Have you been getting chatter over this last week or two? Do you have any thoughts about what you might want to offer up as services? And maybe what do you see the industry doing to take a harder look at hardening up its assets?
Speaking for coal and gas boiler assets, many of these units were built a long time ago, built for different climatic conditions than the excursions that we see anymore. So units down in Texas were built as outdoor units. I've spent a lot of time working in the Northeast where week after week it is, 5 degrees outside and those things just keep on going. So it's totally possible. And there are design features and there are appurtenances that you put on those units to make them run. And it's not impossible to do that. It's a matter of Can it come down to economics? Is it worth the investment to make sure that unit runs all the time? I mean, it could be as simple as putting heat tracing on instrument lines. I'm not exactly sure what tripped those units off, but I mean, I've seen that happen. Somebody's got wet instrument air and it freezes in the lines, takes an instrument out, and boom, there goes the whole plant. There might be simple things that can be done to winterize the units, and maybe it's not much, maybe it's a lot. Of course, if you can't get the gas to a plant, period, not much you're going to do about that at the plant site, but it's definitely a doable thing to make a plant hardened against weather, no question.
Just to speak from nuclear, we're pretty hardened as a generation asset. I know STP had one minor issue. It's not my concern that the people would be able to produce the power safely at the nuclear power plant, but it has to be able to get to the customers. One of the things Dennis was mentioning, us having discussions on hardening and climatic extremes, we do a lot of work in Florida where we helped harden their grid for hurricanes. The hurricanes come every year. It was a known event. So you can get funding available, you do the hardening for the poles and transmission, you make sure that it survives, or more of it survives the next hurricane. It is a very clear business case to be made. And we have a team of engineers that just jump on hurricanes and support issues. This was less obvious to the industry that it was going to occur. It's occurred, and I'm sure that we'll all adjust to it. And hopefully it's not to the frequency of hurricanes, but in a similar manner.
Eric, did you have any thoughts about renewable, maybe any traffic you've seen on your emails lately?
Well, I'm not sure that I have the solution to the issues going on here, but certainly with regard to renewable projects in extreme weather, there are a number of initiatives that can be undertaken with regard to wind projects. Wind turbines can be equipped with that are called cold weather packages that allow them to operate a little bit more extreme weather. With regard to solar projects, there's O&M programs that can be implemented that would include snow removal and maintenance on the panels to help maintain the highest capacity through some of these kind of extreme events. And then, of course, there's the transmission congestion curtailment issues that have periodically been experienced throughout the nation, and the need to really look into the transmission studies associated with new generation of renewable energy and make sure that those sort of curtailment constraints are well understood, planned for, and where possible, that the upgrades are implemented.
Thanks for the timely answers there, and everybody. All right, so that is going to more or less wrap it up for this session on asset management for plant life extension. And I do appreciate PowerGen for giving me this opportunity, and certainly hope to do it again sometime. That was my panel from the virtual PowerGen Plus series, Asset Management for Plant Life Extension, featuring guests from Babcock & Wilcox, Sargent & Lundy, and Intercon. I want to thank all my guests and their communications teams, as well as Teresa Hansen and Rod Walton at PowerGen for giving us such an exciting platform. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 110. Be sure to join us next week when we explore a new battery technology built for space, now finding a home here on Earth. Until then, I'm Jay Downhauer. We'll see you next time.